Okay, so this evening's session we're working through the Numeracy paper 2 from November 2018. We've already filled in the front, so we're already bearing in mind the sort of mark we're aiming for in order to get over the threshold for the particular grades. And the C grade questions pretty much take us towards the end of question 6. So I'll stop the clip at question 6 and then we'll move on to the second half of C and B grade questions. We've already filled out, as we've sat down, the formulae that we need to remember. So our trig formula, our areas and volumes to do with circles, speed, distance, time, and our metric and imperial equivalences. So if I need to refer to those, I know where I can look for them. Question 1. So we've got two different sales. We've got a t-shirt and a pair of shoes. One reduction given in percentages and the other given in fractions. And the first thing they're asking us to do is to calculate the sale price of the t-shirt. So this t-shirt has got 22% off. So there's two ways of doing this. I'll do it both ways and you can pick which way you would prefer. I suspect the way you're most comfortable with is to find out what 22% of 46 is. And when we're talking about of in maths, we're actually using the multiplication sign. So on our calculators, using the percentage button, we can just type it in exactly as I've written it. So 22% times 46, which is £10.12. If you don't like using the percentage button, you could write it as a decimal, 0.22, or as a fraction, 22 over 100. Up to you. But if this is the method that you are using, you then need to remember that that's what the actual reduction is. That's what's coming off. So the sale price will be 46 less £10.12. So it's £35.88. The alternative to that is to make the reduction to the percentage. So if it's been reduced by 22%, then what you're ending up with is 78% of the 46. So the quicker way of doing it, and the way that's better because it's our percentage multiplier, which we'll talk about when we get to the harder questions. So 78% times 46 will give you the £35.88 in one go. So it doesn't matter which method you use, you'll both end up at the same point, but if you work the percentage multiplier out from the reduction, then the line of maths you're doing is actually just one line of maths. So it's 22% times 46, okay, which gives you £10.12. That's the amount of the reduction.
What's the second one?
The second one is you take you reduce your original percentage. So you're taking 22% off 100, giving you 78%, and then you're doing 78% of 46. So it just does it in one line of maths rather than finding the reduction and then subtracting it. It's your choice which you prefer to use. And then similarly, for the fraction, 3/8 it's been reduced by 3/8. So you can either find out how much that is first of all. So you're going to find 3/8 of £43.60 using the fraction button. 3/8 times 43.60, which is £16.35, and then take that off, because that's the amount that's being reduced. So £27.25. Or alternatively, if it's being reduced by 3/8, it leaves you 5/8. So you can just find out straight off what 5/8 of £43.60 is. So fraction button 5/8. And it'll give you the answer straight away. Okay, so it doesn't matter which method you choose. Marks for that, so you get a method mark for working out your percentage reduction, and an answer mark, and a method mark for correctly working out the fraction reduction, and an answer mark. And then part B, before the sale, a pair of jeans costs £43. In a sale, the jeans cost £37. By what fraction have the jeans been reduced in the sale? So with a reduction, whether it's a fraction reduction or a percentage reduction, you're looking for how much of a reduction there's been, which is £6, out of the original. So it's the change out of the original. And that would be the same whether it was an increase or a decrease. So as a fraction, it would be the change, which is 6, out of the original value, price, which is 43. So it's this one. If the question had asked you for a percentage, you would have multiplied it by 100 and worked that out.
How do you know 6 over 43?
Because the value of the reduction, they cost 43, and then they were sold for 37. So they've had £6 taken off them. So it's 6, the reduction, over 43. And 1 mark for that. Okay, question 2. Mixing 200 millilitres of white paint with 10 millilitres of red paint and 5 millilitres of blue paint makes light purple paint. Paint is sold in tins, different sizes, 240, 500 ml and 1 litre. Jana is going to make some light purple paint. She does not want to have any white, red or blue paint left over, and she wants to buy as few tins of paint as possible. She buys a 250 millilitre tin of blue paint. How many tins of paint will she need to buy all together? So the easiest way to lay this question out is as a ratio, because we're mixing white, red and blue in this particular proportion or ratio. So white to red to blue will be 200 to 10 to 5. Now we know she's buying a 250 ml tin of blue. What I need to find out is what the corresponding capacity of red and white will match that 250 and keep in that same relationship, in that same ratio. So what I'm looking for is what's the multiplier, what's the scale up to take that 5 to 250. So on your calculator, you're going to be doing 250 divided by 5. Sorry? What is the answer? 50. Okay, so in order to have this matching quantities of red, white and blue to make that exact same colour of light purple as any other arrangement, then all of these values need to be 50 times bigger. So for 250 millilitres of blue, I need times that by 50, 500 millilitres of red, and 200 times 50 is 10,000 millilitres of white. So I now know how much of each colour I need to buy. What the question is also telling us is she wants to buy as few tins of paint as possible. So for example, she needs 500 millilitres of red. She could buy 2 small tins rather than 1 big tin. But because the question is saying as few tins as possible, that is going to be 1 tin. So that's going to be 1 500 ml tin. The 250 is going to be 1 250 ml tin. And then we're looking at this 10,000. This is 10,000 millilitres. You need to know that there are 1,000 millilitres in a litre. So that's equivalent to 10 litres. And they're sold in 1 litre tins. So that'll be 10 lots of 1 litre. So to come back to the question, how many tins of paint will Jana need to buy altogether? So blue paint, 250 ml tin, 1 tin. Red paint, we're going to go with 500 millilitre tin, 1 tin of. And then the white paint, 10 tins, 1 litre, and 10 of those tins. So answering the question, how many tins does she need to buy altogether? She needs to buy 12. 10 1 litre tins, 1 500 millilitre tin, and 1 250 millilitre tin. There's quite a lot going on in that question. The way that it's marked is you get 1 mark for the 1 500 millilitre tin of red paint. There's a method mark for scaling up to get your 10,000 millilitres, so using the ratio, and an answer mark if I see 10,000 millilitres. And then there's an additional 2 marks if you correctly turn that into litres and recognise you need 10 tins of it. And then there's a final mark for adding them together to say the number of tins in total. So that's quite a big mathsy question quite early on, a bit like you got hit yesterday with the question 1, which was a lot of work straight in. Question 3. Air and Electronics only sells digital tablets and covers. The Venn diagram shows the number of items sold by Air and Electronics during the first week in May. Each tablet was sold for £220. Each cover was sold for £18. How much money in total did Air and Electronics make in the first week of May? So you need to understand how a Venn diagram works. We can see here that we've got 2 overlapping circles. This circle represents all the tablets sold. This circle represents all the covers sold. And the overlap are tablets and covers. So if we want to work out the total cost, different ways of doing it, but the most common way I saw last autumn was, first of all, deal with tablets only. So there were 55 tablets sold for £220. So that's 12,100, sorry. Then deal with the covers only. £14 of those sold for £18. And then we've got that 48 to deal with. Now the 48 bought both. And that'll come to £238 because they're paying for both of them. So 48 times 238, 11,424. And then how much money in total? So we're going to add those together. We're allowed to use a calculator, so we're not going to risk doing it without. So we get a final answer of £23,776. 3 marks there, 1 mark for the tablets only, 1 mark for the covers only, 1 mark for then correctly adding all of those together. Question 4, pie chart. Rushmore Energy is a company that supplies electricity. Last year, Rushmore Energy displayed the following information in a pie chart. The pie chart represents a total of 9,100 million. How much profit did Rushmore Energy make last year? Give your answer in millions of pounds. Okay. So profit, if we look at the way the slices are arranged, we can see that the profit there, they aren't telling us what that slice represents. But because all the slices are given in terms of a percentage rather than angle, we're not going to be working with 360, we're going to be working out of 100. So I've got 50, 75, 85, 90, 95. So that missing value there is 5%. So I need to work out what 5% of the whole pie is going to be. Now because they want the answer in terms of million, I don't have to put all the zeros in. I can just work out 5% of that and then add the million word to the end. So I want to find out what 5% of 9100 is. 455 million. Last year, Rushmore Energy had 8.58 million customers. The previous year, Rushmore Energy had 8.21 million customers. How many extra customers were there last year? So if I take 8.58, 8.21 away from 8.58, I get 0.37 million, which I've then got to turn into a proper number, because this time none of them have got million written next to them. So to turn that into a million, I just want to times it by a million, which is 6 noughts. So I'm looking for 370,000. So marks for that. There's 1 mark for me seeing 5% anyway. You could have written it in the pie chart or written it there as part of your answer. 1 mark for 5%. Then a method mark for correctly finding 5% of 9,100 million, and an answer mark, and that one I'm just looking for 370,000. But just because they're giving you something there to put a circle around doesn't mean you don't do any work in order to find the correct answer, which is why you've got that space underneath. Sometimes you don't need the space, sometimes you do. Part C. Maggie looks back at her electricity bill. It shows how much energy she has used last period and this period. This is the display she sees. So 900 kilowatt hours, 828 kilowatt hours, reduced by 8%. Is this decrease of 8% correct for the reduction in kilowatt hours? You must show all your working to support your answer. There's several different ways of doing this. The most common way that I saw was to find out what 8% of 900 is. So reducing 900 by 8%. So it's coming down by 72, and if you do 900, take away 72, you get 828. So it is correct. Okay, so that's the most common way. Another way of doing it is to find out what the reduction is and work it out as percentage. But that's the most common. So 2 marks there. 1 for the method of how you worked it out, and 1 for correctly ticking yes. Part D. So here we've got our OCW question. Maggie used 828 kilowatt hours of electricity in this period. Electricity was charged at £0.18, 18 pence per kilowatt hour. The standing charge for this period was £65. VAT at 5% is payable on the total cost of the electricity used and the standing charge. What do we need to do? Calculate her bill. So the charge for the electricity used will be the amount she's used, 828, times the charge for every one of those kilowatt hours. So times 0.18 pounds. So she gets charged £149 and 4 pence for the electricity she's charged. On top of that, she's charged an additional £65, which is fixed every bill. So that's charged as £65 regardless how much or how little electricity she's used. So her bill before VAT will be the 14904 plus the £65 standing charge. Then we've got to deal with VAT. Now VAT is charged at 5% on the total cost of the electricity and the standing charge. So we've got to find 5% of that total. So VAT at 5%. Is that. Now we're talking money. So when we're talking money, unless told otherwise, we'd work to 2 decimal places. So the VAT is going to be £10.70. So her total bill will be the £214.5 for what she's used plus the standing charge and the VAT of £10.70. So £224. That's a 4 there.
Can you zoom that in?
Yeah. Is that all right?
Yes.
So that's 214.04 there. So just check that doesn't affect. Yeah, that stays the same. So this becomes 224.74. The 5 marks for that. You've got 2 marks for working out the 149.04. 1 for the method of the multiplication. 1 for that answer. There's 1 mark for then adding on the standing charge. There's a method and an answer. Sorry, there's a method for finding the 5% and an answer for adding that on to get the total bill. So those are the 5 marks that you get for doing the maths. And then the OCW, as I've said now numerous times, the first mark is for just putting a small explanation down for the line of maths that you're doing. So in that line of maths, I'm working out the charge for the electricity. The next line, I'm adding on the standing charge, which gives the bill before the VAT. VAT at 5%, so total bill. So just making it clear to whoever's looking at that what you're doing. And then the second OCW mark is for consistent use of units. So I've got the pound symbol everywhere I need, percent symbol there, and so on. Okay, question 5, income tax. So Zara is paid in dollars. Last year, Zara's total income before tax was $25,000. The tax band, taxable income and tax rates for the last year are as follows. So anything she earned up to $10,000 was charged at 0%. So there was no charge for those earnings. So if she only earned $9,000 a year, she wouldn't pay any tax. Beyond that, for anything she earned between $10,000 and $22,000, then that amount was charged at 20%, and everything over $22,000 was charged at 25%. First thing they want you to do is show that Zara should have paid £2,400 tax dollars at the basic rate. So she's earning $25,000, which is above that basic rate of income tax. So all of what's available in there will be charged at 20%. So her basic rate of income tax will be that amount times 20%. So that's going to be 12,000 times 20%. $2,400, which is what they've asked us to show. So that's great, because that's giving us a little bit of confidence that we're doing the right thing. So she's not being charged any tax on her first 10,000. She's being charged 2,400 up to 22,000, and on everything above 22,000 she's going to be charged at 25%. Zara's total tax bill last year was $4,000. She thinks an error has been made. Calculate how much tax should be refunded to Zara. So we know how much the basic rate is, so now we need to work out what the higher rate. At the higher rate, it's the difference between what she's earning, 25 grand, and that threshold, so 22,000, times 25%. So she's actually paying 25% on 3,000, the gap between that threshold and her earnings. Go on. Sure? So I can do 3,000 times 25%, which is $750. So her tax bill should be the 2,400 basic plus 750 higher, so she should have been charged $3,150. We check back to the question. Question's not asking us what the tax bill should be, it's by how much she should be refunded, because she was charged $4,000. So her refund is the difference between what she was charged and what she should have been charged. So $850. But I need to zoom this back out, otherwise it's going to drop off. I've gone the wrong way now. So for that question, there's one mark if I see $12,000. So just working out how much the charge is going to be within that threshold, and one mark for correctly working out the 2,400. And then part B, there's 2 marks for working out that I need to find 25% of 3,000 and working that out correctly as $750. Then there's 1 mark for establishing what the bill should have been, and 1 mark for working out what the refund should be. These tax questions are cropping up more often. It's the first thing we did with you back in September. It's worth you having a scan of those notes maybe when you go home. Question 6. So this is the last of the overlap with the foundation. So Emma has set his lawnmower to work at a constant speed of 2,000 miles an hour. So that is triggering straight away speed, distance over time. What was that little triangle I wrote down? Speed, distance over time. So I'm starting to think about that. He walks a distance of 300 meters when he cuts his lawn. Use this information to calculate how long Emma takes to cut his lawn. So, going back. That's the relationship between speed, distance, and time. And I want to find how long. How long is time? So time is distance over speed. The distance that he's walking is 300 meters. And the speed is 2,000. Okay? I'm going to be careful when I zoom in, otherwise things go off the bottom. So the distance is 300, the speed is 2,000. So when I put that into my calculator, I get 3 out of 20, or as a decimal, 0.15. Now, we need to give our answer in minutes. So this is a time button question. Okay, that's meters, and underneath there is meters per hour. So what I need to do now is to use my time button to turn that into time, which is 0 hours and 9 minutes. So just do that again for you. Okay, that's what came out of my calculation. And if you just press the time button again, it turns it into time. So 0.15 is 0 hours, 9 minutes. And all you need to put down there is 9 minutes. The other way of doing that, if you can't remember, is, well, I want to turn that into minutes, so I got times it by 60, because there are 60 minutes in an hour. So if I did 0.15 times 60, I get 9 out. Okay, but that's done for you, so long as you realize, oh, this is a time button, I'm allowed to use my time. This is a time question, I can use the time button. What assumption have we made? Well, what we're assuming is lots of things, really. He doesn't stop. He doesn't change his speed, so when he turns around, we're assuming he's moving at the same speed all the time. Doesn't run out of petrol. Anything like that is a suitable assumption. What impact would this have on the time you calculated in answering part 1? Well, the impact is that if he did change his speed, or he stopped, it would take him longer. So the mark for part A, there's a method mark for your distance over speed, and an answer mark for correctly getting that to 9 minutes. If I saw 0.15 anywhere, you'd get one of the two. But most common answer, wrong answer then, would be to write that down as 15 minutes. And then E1 and E1, two exclamation marks. Part B. Emyr cuts his lawn 25 times a year. He uses 4.5 litres of petrol in his lawnmower each year. How much petrol does the lawnmower use for every 100 metres that Emyr walks? So he's cutting his lawn 25 times a year, and every time he cuts it, he's walking a distance of 300 metres. So I can find out how far he walks in a year, or distance covered in 1 year. Will be 25 lots of 300. Which is 7,500 meters. Now I want to divide that up into 100-meter blocks, because I want to know how much fuel he uses for every 100 meters. So the number of 100-meter blocks he's going to walk in a year so that's what I mean by block, is how many times does 100 go into that, which is 75. So he's going to push his lawnmower 75 lots of 100 meters every year. And that's going to use 4.5 litres. How much petrol does he use for every 100 metres? Well, he uses 4.5 in total, and I now need to divide that by the 75 100-meter blocks. Give your answer in litres, so you end up with a small amount of fuel. Okay, he's only going to use 0.06 litres for every 100 metres he goes. So that's a tricky little question. There are lots of students will correctly get in the 7,500. So they were picking up a mark for that, which was good. And then the method of finding out how many hundreds, 75 of them, dividing that into 4.5, students are uncomfortable with that. They would rather divide the big number by the small number. So 0.06 you need for those 3 marks. So not many intermediate students were picking up 3 out of 3 there. There's 2 more parts to question 6. Petrol costs £1.30 per litre. Emyr says, the petrol for my lawnmower costs me approximately 60 pence per pint. Is Emyr correct? So we've got litres and pints. So this is one of our metric to imperial conversions that we need to rattle off. 1 litre is approximately 1.75 pints. Now, just seeing that written down, even if you don't know what to do with it, will have got you a mark for this question. So just having remembered, oh, I'd written that down earlier, let's get that over here, because you're about to try and do the right thing. Now, I need to work out pints. So I want to change this relationship so that I know what 1 pint is equivalent to. To do that, just the same sort of thing as with those paint tins earlier, I need to find out what I've got to do to turn 1.75 to 1. And because it's a smaller quantity, I'm not going to be multiplying, it's a divider. In order to turn 1.75 to 1, I divide it by 1.75. If I do that to that side of the relationship, I have to do it to this side as well. So I need to do 1 divided by 1.75, which is 4 over 7.
Because if you were to divide 2 by 2,
Yeah, divide anything by itself and you get 1. So if you want to find 1, you're going to divide that by whatever that is, and then you have to do the same the other side. So that is 4/7. Now I know that petrol costs £1.30 a litre, and what I've got here is 4/7 of a litre. So if I do 4/7 times now my £1.30, I get that much pounds. So this is quite a lot of work for 3 marks. It's quite not many, again, in the intermediate tier were scoring 3 out of 3 for this. Lots of them were getting 1. They knew the relationship they needed to use, but because it wasn't a straightforward conversion, they had to turn it into 1 point is what litres. They found that difficult. So let's go back to the question. Emma says, the petrol for my lawnmower costs me approximately 60 pence a pint. Is he correct? Well, no, it's costing more than that a pint. It's costing quite a bit more. So, no. Show your workings, we have. Emma's friend claims that she walks 1 7/8 miles when she cuts her lawn. Approximately how far is this in meters? So this is another one of our conversions. This time we're converting miles to meters. So we're going back to our crib sheet that we filled in right at the start. 8 kilometers is approximately 5 miles. I want to find out what 1 mile is, which I would do by dividing by 5, which means I have to divide this by 5 as well, which gives me 8 over 5. And then I haven't got 1 mile, I've got this 1 7/8 miles. So then I've got to do 1 7/8 times the 8 over 5. Now, your fraction button on your calculator, we usually just press it once and it kicks off with that. But if you look above it, if we shift and press it, you can see we've got 3 boxes. That allows us to use mixed numbers like we've been given there. So if we do shift, shift and fraction button, you can see we can put in 1 7/8 in the same way that we were given it in the question. And then we're going to times that by 8 over 5. Okay, so I've written it there exactly as it is in the question. And out the bottom drops 3. That's 3 kilometers. So once you've converted it, you still need to then think, well, which one of those is 3 kilometers? It's clearly that one. It's the only one where it's just 3. So there's 4 marks there, all to do with metric and imperial equivalences. So that's quite a lot for that. 1 mark just for writing that. 1 mark for the correct method of finding out how much that would cost. And 1 mark for the answer. And 1 mark there for figuring out which one it is. So that takes us to the end of the foundation overlap. We'll take a break there.